Polarizability can be described as how well a molecule's electron cloud gets distorted. For example, if a molecule's electron cloud gets distorted fairly easily compared to another one, it would have a higher polarizability compared to that other molecule. We are going to use benzene as an example. It has very distinct electron clouds. Benzene is a hydrocarbon, so it only contains carbons and hydrogens. And this symbol here of benzene, it's a very traditional symbol, and it is, as you can see, it's a hexagon with a circle in the middle. So we are going to see why this symbol of benzene makes sense and look at how benzene will react when it comes near a positive charge. We are going to see how it can create what's similar to a dipole, or the separation of positive and negative charges within the molecule itself. Here is the chemical structure of benzene. As you can see, there are 6 carbon-carbon bonds shaped as a hexagon, and there are 3 double bonds and 3 single bonds. However, you see 2 structures here, and these are residence forms of benzene. So the actual, or more accurate, structure of benzene, you can think of that as being a hybrid of these 2 structures here. You see that each carbon-carbon bond is not a double bond or a single bond. It's in between the 2. The electrons in these bonds are constantly moving around, as you can see here. And this is how we have the image of benzene at the beginning of this movie, the one with the hexagon with a circle in the middle of it. Let's take a little bit better look into benzene's bonds. So each of the carbon-carbon bonds consists of a sigma bond and also a pi bond. So sigma bonds in general are more stronger than the pi bonds. So the pi bonds, as you can see, are located on the top and bottom of the molecule. So these are the bonds, or the electrons that are making the bonds. They are considered delocalized, contain the electrons that will eventually get distorted if it gets put near a positive charge. So let's take a look at polarizability and how these electron clouds can create a distortion when it comes near a cation. Each carbon atom in benzene is sp2. As you can see, this creates an electron cloud above as well as below the carbon atoms. And so this obviously has a negative charge on the top and bottom of benzene. And so for example, of polarizability, if we bring in a noticeably partial positive charge near it, such as acetone for example, we can see the electrons in the 2 electron clouds wanting to distort or go near that partial positive charge in acetone. And so you can kind of see this is the dipole created